Today we're looking at systems of linear inequalities. A system of linear inequalities is similar to a system of equations. It just means that we have two or more inequalities. The solution to a system of linear inequalities is the point or points that both inequalities share. So it's where both have the shading. Now, it's sometimes we're checking to see if a coordinate works in a solution to a system. If you do that, if you're checking this point, you put 1 in for x and 2 in for y, you have to check it in both inequalities. Okay, so must check in both inequalities. Or if there's 3, you must check it in all 3. All right, so if we put a 2, if we put a 1 in here, -1 plus 5 is 4. 2 is greater than or equal to 4. This does not work. So we probably wouldn't even need to check the other point because it's not going to work in the first one. It's not going to work. All right, next we have, we're supposed to be graphing this system. So in order to graph a system, we have to have the equation solved for y. So the first one's good, but the second one, we're going to have to manipulate this around. Add the 3x, just like we solved an equation for y. And there's just a coefficient of 1, so we don't have to really worry about that. You divide everything by 1 if you had to, but all right, so graphing the first one here, our y-intercept is 5. Our slope is -1, so up 1 and over 1 or down 1 and over 1 to create this negative slope. It is equal to, so it's going to be a solid line. And then greater than would be above the line, so up in there. Now this one, the y-intercept is at -4, doing this one in red. The slope is 3, so +3, rise 3 over 1. This is also equal to, so it's going to be a solid line. And then this one is shaded less than, so less than is below. And then the final answer is where they have the double shading. So all of this would be where your final answer is. The stuff in red works in this equation, the stuff in blue works in this equation, but the stuff in yellow works in both equations, which is the solution to our system. All right, we're going to go backwards with this one. All right, I shaded a little bit here because it was hard to tell where the double shading was. So now we have the double shading and we can see. I'm going to do this line first. This is a solid line, so it's going to be less than or equal to or greater than or equal to. So y, let's see, it's shaded below it, so that would be less than or equal to. Our slope for this, if we go up 1 and over 2, rise 1, run 2, that's our slope. It's going uphill, so it's positive. And our y-intercept, it crosses through the y-axis at 1. Our other line, our dashed line here, is going to be either just less than or just greater than, no equal to. It's shaded below it as well, so it's going to be less than. If we look at the slope of this one, we are still going up 1 and over 2. The difference here is it's a negative slope, so -1/2 x. Y-intercept is still at 1, so there is your system of inequalities. Now, they want to know in the final question, is the point where the two intersect, is that point a solution to the system? Well, the point where they intersect is 0, 1. So we're testing to see if 0, 1 is a solution. Technically, you might be able to look at this and tell, because this line, everything is included in this line is in the answer to this. Everything that's on this line is not included in the answer to this. So points on this line do not work in this equation, which means this point is not going to work. You can check it in the first one. I believe that works out fine. But if you check it in this one, 1 less than, just less than, -1/2 x is 0 plus 1. Well, this turns out to be just 1. 1 is less than 1 is not true. That's false. So it does not work in this system. All right, and sometimes you can tell that just by looking at the picture.